Welcome back, and in this demo lesson you're going to evolve the infrastructure which you've been using throughout this section of the course. In this demo lesson you're going to add private internet access capability using NAT gateways. So you're going to be applying a CloudFormation template which creates this base infrastructure. It's going to be the Animals for Life VPC with infrastructure in each of 3 availability zones. So there's a database subnet, an application subnet, and a web subnet in availability zone A, B, and C. Now to this point what you've done is configured public subnet internet access, and you've done that using an internet gateway together with routes on these public subnets. In this demo lesson you're going to add NAT gateways into each availability zone, so A, B and C, and this will allow this private EC2 instance to have access to the internet. Now you're going to be deploying NAT gateways into each availability zone so that each availability zone has its own isolated private subnet access to the internet. It means that if any of the availability zones fail, then each of the others will continue operating, because these route tables which are attached to the private subnets, they point at the NAT gateway within that availability zone. So each availability zone A, B and C has its own corresponding NAT gateway which provides private internet access to all of the private subnets within that availability zone. Now in order to implement this infrastructure you're going to be applying a one-click deployment, and that's going to create everything that you see on screen now apart from these NAT gateways and the route table configurations. So let's go ahead and move across to our AWS console and get started implementing this architecture. Okay, so now we're at the AWS console. As always, just make sure that you're logged in to the general AWS account as the IAM admin user, and you'll need to have the Northern Virginia region selected. Now at the end of the previous demo lesson you should have deleted all of the infrastructure that you've created up until that point, so the Animals for Life VPC as well as the Bastion host and the associated networking. So you should have a relatively clean AWS account. So what we're going to do first is use a one-click deployment to create the infrastructure that we'll need within this demo lesson. So attached to this demo lesson is a one-click deployment link, so go ahead and open that link. That's going to take you to a quick create stack screen. Everything should be pre-populated. The stack name should be A4L. Just scroll down to the bottom, check this capabilities box, and then click on create stack. Now this will start the creation process of this A4L stack, and we will need this to be in a create complete state before we continue. So go ahead, pause the video, wait for your stack to change into create complete, and then we're good to continue. Okay, so now this stack's moved into a create complete state, then we're good to continue. So what we need to do before we start is make sure that all of our infrastructure has finished provisioning. To do that, just go ahead and click on the Resources tab of this CloudFormation stack and look for A4L internal test. This is an EC2 instance, a private EC2 instance, so this doesn't have any public internet connectivity, and we're going to use this to test our NAT gateway functionality. So go ahead and click on this icon under Physical ID, and this is going to move you to the EC2 console, and you'll be able to see this A4L-internal-test instance. Now currently in my case it's showing as running, but the status check is showing as initializing. Now we'll need this instance to finish provisioning before we can continue with the demo. What should happen is this status check should change from initializing to 2 out of 2 status checks. And once you're at that point, you should be able to right click and select connect and choose session manager and then have the option of connecting. Now you'll see that I don't, because this instance hasn't finished its provisioning process. So what I want you to do is to go ahead and pause this video, wait for your status checks to change to 2 out of 2 checks, and then just go ahead and try to connect to this instance using Session Manager. Only resume the video once you've been able to click on Connect under the Session Manager tab. And don't worry if this takes a few more minutes after the instance finishes provisioning before you can connect to Session Manager. So go ahead and pause the video, and when you can connect to the instance, you're good to continue. Okay, so in my case, it took about 5 minutes for this to change to 2 out of 2 checks passed, and then another 5 minutes before I could connect to this EC2 instance. So I can right click on here and put connect. I'll have the option now of picking Session Manager, and then I can click on Connect, and this will connect me in to this private EC2 instance. Now, the reason why you're able to connect to this private instance is because we're using Session Manager, and I'll explain exactly how this product works elsewhere in the course, but essentially it allows us to connect into an EC2 instance with no public internet connectivity, and it's using VPC interface endpoints to do that, which I'll be explaining elsewhere in the course. But what you should find when you're connected to this instance, if you try to ping any internet IP address, so let's go ahead and type ping and then a space 1.1.1.1 and press enter, you'll note that we don't have any public internet connectivity. And that's because this instance doesn't have a public IP version 4 address, and it's not in a subnet with a route table which points at the internet gateway. This EC2 instance has been deployed into the application A subnet, which is a private subnet, and it also doesn't have a public IP version 4 address. So at this point, what we need to do is go ahead and deploy our NAT gateways, and these NAT gateways are what will provide this private EC2 instance with connectivity to the public IP version 4 internet. So let's go ahead and do that. Now, to do that, we need to be back at the main AWS console, click in the services search box at the top, type VPC, and then right click and open that in a new tab. Once you've done that, go ahead and move to that tab. Once you're there, click on NAT Gateways and create a NAT gateway. Okay, so once you're here, you'll need to specify a few things. You'll need to give the NAT gateway a name. You'll need to pick a public subnet for the NAT gateway to go into, and then you'll need to give the NAT gateway an elastic IP address, which is an IP address which doesn't change. So first we'll set the name of the NAT gateway, and we'll choose to use A4L for Animals for Life, hyphen VPC1, hyphen NATGW, and then hyphen uppercase A, because this is going into availability zone A. Next, we'll need to pick the public subnet that the NAT gateway will be going into, so click on the subnet drop-down, and then select the Web A subnet, which is the public subnet in availability zone A, so SN-web-A. Now we need to give this NAT gateway an elastic IP. It doesn't currently have one, so we need to click on Allocate Elastic IP, which gives it an allocation. Don't worry about the connectivity type, we'll be covering that elsewhere in the course. Just scroll down to the bottom and create the NAT gateway. Now this process will take some time, and so we need to go ahead and create the two other NAT gateways. So click on NAT gateways at the top, and then we're going to create a second NAT gateway. So go ahead and click on Create NAT Gateway again. This time we'll call the NAT gateway A4L-VPC1-NATGW-B, and this time we'll pick the Web B subnet, so SN-web-B, allocate it an elastic IP again, and click on Create NAT Gateway. Then we'll follow the same process a third time. So click Create NAT Gateway, use the same naming scheme but with -C, pick the Web C subnet from the list, allocate an elastic IP, and then scroll down and click on Create NAT Gateway. And at this point we've got the three NAT gateways that are being created. They're all in a pending state. If we go to elastic IPs, we can see the three elastic IPs which have been allocated to the NAT gateways, and we can scroll to the right or left and see details on these IPs, and if we wanted we could release these IPs back to the account once we'd finished with them. Now at this point you need to go ahead and pause the video and resume it once all three of those NAT gateways have moved away from a pending state. We need them to be in an available state, ready to go before we can continue with this demo. So go ahead and pause and resume once all three have changed to an available state. Okay, so all these are now in an available state, so that means they're good to go, they're providing service. Now if you scroll to the right in this list, you're able to see additional information about these NAT gateways. So you can see the elastic and private IP address, the VPC, and then the subnet that each of these NAT gateways are located in. What we need to do now is configure the routing so that the private instances can communicate via the NAT gateways. So right click on Route Tables and open in a new tab. And we need to create a new route table for each of the availability zones. So go ahead and click on Create Route Table. First, we need to pick the VPC for this route table, so click on the VPC drop-down and then select the Animals for Life VPC, so A4L-VPC1. Once selected, go ahead and name the route table. We're going to keep the naming scheme consistent, so A4L-VPC1-RT for route table-private A. So enter that and click on Create. Then close that dialog down and create another route table. This time we'll use the same naming scheme, but of course this time it will be RT-private B. Select the Animals for Life VPC and click on Create, close that down. And then finally click on Create Route Table again. This time A4L-VPC1-RT-private C. Again, click on the VPC dropdown and select the Animals for Life VPC and then click on Create. So that's going to leave us with 3 route tables, one for each availability zone. What we need to do now is create a default route within each of these route tables, and that route is going to point at the NAT gateway in the same availability zone. So select the route table private A and then click on the Routes tab. Once you've selected the Routes tab, let's just expand this, make it easier to see. Click on Edit Routes, and we're going to add a new route. It's going to be the IP version 4 default route of 0.0.0.0/0. And then click on Target and pick NAT Gateway. And we're going to pick the NAT Gateway in Availability Zone A. And because we named them, it makes it easy to select the relevant one from this list. So go ahead and pick A4L-VPC1-NATGW-A. So because this is the route table in Availability Zone A, we need to pick the same NAT gateway. So save that and close. And now we'll be doing the same process for the route table in Availability Zone B. Make sure the Routes tab is selected and click on Edit Routes. Click on Add Route, again 0.0.0.0/0. And then for Target, pick NAT Gateway, and then pick the NAT gateway that's in Availability Zone B, so NAT GW-B. Once you've done that, save the route table, and then next select the route table in Availability Zone C, so select RT-private C, make sure the Routes tab is selected and click on Edit Routes. Again, we'll be adding a route. It will be the IP version 4 default route, so 0.0.0.0/0. Select a target. Go to NAT Gateway and pick the NAT Gateway in Availability Zone C, so NAT GW-C. Once you've done that, save the route table, and now our private EC2 instance should be able to ping 1.1.1.1 because we have the routing infrastructure in place. So let's move back to our private instance. And we can see that it's not actually working. Now the reason for this is that although we have created these routes, we haven't actually associated these route tables with any of the subnets. Subnets in a VPC which don't have an explicit route table association are associated with the main route table. Now we need to explicitly associate each of these route tables with the subnets inside that same AZ. So let's go ahead and pick RT-private A. We'll go through in order. So select it, click on the Subnet Associations tab and edit Subnet Associations. And then you need to pick all of the private subnets in AZA. So that's the reserved subnet, so reserved-A, the app subnet, so app-A, and the DB subnet, so DB-A. So all of these are the private subnets in Availability Zone A. Notice how all the public subnets are associated with this custom route table you created earlier, but the ones we're setting up now are still associated with the main route table. So we're going to resolve that now by associating this route table with those subnets. So click on Save, and this will associate all of the private subnets in AZA with the AZA route table. So now we're going to do the same process for AZB and AZC, and we'll start with AZB. So select the private B route table, click on Subnet Associations, Edit Subnet Associations. So select Application B, Database B, and then Reserved B. And then scroll down and save the associations. And then select the private C route table. Click on Subnet Associations, Edit Subnet Associations, and then select Reserved C, Database C, and then Application C. And then scroll down and save those associations. And now that we've associated these route tables with the subnets, and now that we've added those default routes, if we go back to Session Manager where we still have the connection open to the private EC2 instance, we should see that the ping has started to work. And that's because we now have a NAT gateway providing service to each of the private subnets in all of the 3 availability zones. Okay, so that's everything you needed to cover in this demo lesson. Now it's time to clean up the account and return it to the same state as it was at the start of this demo lesson. From this point onward in the course, you're going to be using automation, and so we can remove all of the configuration that we've done inside this demo lesson. So the first thing we need to do is to reverse the route table changes that we've done. So we need to go ahead and select the RT-private A route table. Go ahead and select subnet associations and then edit the subnet associations, and then just uncheck all of these subnets. And this will return these to being associated with the main route table. So scroll down and click on Save. Do the same for RT-private B. So deselect all of these associations and click on Save. And then the same for RT-private C. So select it, go to Subnet Associations and then edit them, and remove all of these subnets and click on Save. Next, select all of these private route tables. These are the ones that we created in this lesson. So select them all, click on the Actions drop-down, and then Delete Route Table, and confirm by clicking Delete Route Tables. Go to NAT Gateways on the left, and we need to select each of the NAT gateways in turn. So A, and then click on Actions and Delete NAT Gateway, type Delete, click Delete. Then select B and do the same process, Actions, Delete NAT Gateway, type Delete, click Delete. And finally the same for C. So select the C NAT Gateway, click on Actions, and Delete NAT Gateway. You'll need to type Delete to confirm, click on Delete. Now we're going to need all of these to be in a fully deleted state before we can continue. So hit refresh and make sure that all 3 NAT gateways are deleted. If yours aren't deleted, if they're still listed in a deleting state, then go ahead and pause the video and resume once all of these have changed to deleted. At this point, all of the NAT gateways have deleted, so you can go ahead and click on Elastic IPs. And we need to release each of these IPs. So select one of them and then click on Actions and Release Elastic IP Addresses and click Release, and do the same process for the other 2. Click on Release, then finally Actions, Release IP, click on Release. Once that's done, move back to the CloudFormation console, select the stack which was created by the one-click deployment at the start of the lesson, and click on Delete, and then confirm that deletion, and that will remove the CloudFormation stack and any resources created as part of this demo. And at that point, once that finishes deleting, the account has been returned into the same state as it was at the start of this demo lesson. So I hope this demo lesson has been useful. Just to reiterate what you've done, you've created 3 NAT gateways for a region-resilient design. You've created 3 route tables, 1 in each availability zone, added a default IP version 4 route pointing at the corresponding NAT gateway, and associated each of those route tables with the private subnets in those availability zones. So you've implemented a regionally resilient NAT gateway architecture. So that's a great job. That's a pretty complex demo, but it's going to be functionality that will be really useful if you're using AWS in the real world, or if you have to answer any exam questions on NAT gateways. With that being said, at this point, you have cleared up the account, you've deleted all the resources, so go ahead, complete this video, and when you're ready, I'll see you in the next.